Yeah, yeah. Okay, so let me share my screen.
Sir, before that, when we can expect the quiz 2 results?
In 1 week or yeah.
Oh, so late. Why is? Because
Sorry.
No, because can it be declared a little early, because we can plan which subject we are weak on, which subject we have to put more effort.
Okay, we'll.
Because 1 week is too long, right?
Yeah, we'll check it. Okay, no worry about that. We'll inform.
What is the schedule, sir? Our assignments are placed so close to each other.
Sorry?
The assignment deadlines are so close to each other. Why is it like that this time?
Actually,
12th week is 23rd and 11th week is 20. 10th week is like tomorrow.
Yeah. Actually, this type of things happen due to you can say like actually we have to conduct revision sessions kinds of thing also for your end term exam. So that's why it's happened like that. Okay.
Is it enough time?
You can join by this code JTL UGI. Okay, kindly join it so that we can start, and rest of the things we can discuss. Okay, no worry about that.
सर एक सब्जेक्ट में सर कितने आवर्स मिलते हैं सर फाइनल्स में?
I think 190 minutes, right? 1 hour and 90 minutes. Okay, so join it first by this code JTL UJI. Okay, I think we can start. Okay, yeah, this is solve with a session of week 10. Okay, and keep your a pen and paper with you so that you can solve the questions. Okay, and you will provide for a sufficient time. So okay, and then you will face a page where you have to enter the answer. It's top below corner. Okay, now yeah, this is the prelude one for the question one. So you have 5 to 6 minutes, which will be more than enough to solve this question. And the people who have not joined, kindly join it by this code, top right corner code JTL UJI. Yeah, hello. By the way, how was quiz 2 exam?
Sir, good.
It's for everyone?
Yes, sir.
Okay.
Yes,
What's about difficulty level?
Sir, medium.
moderate, sir.
Moderate, right?
Yes, sir.
Okay. Are you satisfied with that paper, right?
Actually, yes, sir.
Okay, nice, nice, nice.
Yes,
Yeah,
sir.
and go ahead.
Thank you,
Thank,
sir.
thank you, sir.
Sir, there is some question related to order matter, simultaneous, and some list of the events. Is that question carry any marks?
Yeah, if the previous one, suppose previous one you got wrong, then we will check the EMQ one. Otherwise, if previous is correct, then we will not check the EMQ things.
Okay.
Okay.
How much weightage would be for that question?
For what EMQ?
Yes.
If suppose previous one is correct, then for EMQ there is 0 points. Okay.
Okay.
And if EMQ is wrong, then there is 1 or 2 marks.
1 or 2 marks. Okay.
Yes, depending on the questions level.
Okay, sir.
Okay. Yeah.
सर
Continue.
मॉक पेपर से भी बहुत हेल्प मिली थी.
Yeah. So mock was same exact day.
Sir, the syllabus of in-term exam is total 1 to 12 weeks.
All of you getting the meaning of proportionality here?
Yes, sir.
Yeah. Okay. That's fine. Yeah. Please go ahead.
Sir, can you please explain one more time?
I
Yes,
said
sir.
this question.
Yes, sir. This one.
Try to understand the meaning of proportionality here. Okay.
Okay.
Suppose 1, 2, 3, and 4 such the probability is so proportionality is some constant. Okay. Suppose I'm saying x is proportional to k kind of, and try to attempt. After that, we will check the solution. No worry about that.
Okay, sir. Okay, sir. I will do.
Yeah. How many of you have covered the syllabus? I mean, contents of week 10?
Yes, sir. I have covered all this contents.
Okay, that's nice.
No, sir, not covered yet.
Not covered
Okay,
yet,
okay.
sir.
Just do solve with this. No, you will get yeah, you will get a more idea regarding that. I think there is not too much videos, right? And there is not too much also concept also. You can cover it in this time.
Sure, sir.
There are only 31 responses. Yeah, people who have not joined this, kindly join this by entering this top right corner code. Okay, JTLUJI. I'm hoping all of you are familiar with this, how to join this peer deck, right? Hello.
Yes, sir. Yes, sir.
Okay, that's nice. So rest of the people
Yes,
can
sir.
join and do with us so that you can get more idea about this weekend. I think I can see the responses. Okay.
This
Should we
time
go
in
for?
comparison with the AQ and practice assignment, graded assignment, few questions looks really difficult to approach.
Yeah. I agree with that. Actually,
First
this
two questions, not getting how to approach first step for 1 and 2.
in week 10, right?
Yes, first two questions are difficult. The way how to approach also.
Yeah, try to think. I think after this session, you will get the
Yeah,
idea.
might be. After
Yeah.
solve with us, maybe it's easy.
Yeah.
Because those are entirely different from the activity and practice.
Actually, see. Actually, we put some questions so that you for more understanding, you have to put a little bit more efforts. That's why we put kind of questions.
Okay, I
Okay,
hope
yeah.
after this solve with us.
Yes. Oh, I think we
Thank
can
you.
check for the responses, right?
Okay.
Yeah. Okay, 3, 4, 30. Oh, someone entered this extreme values. A lot of variations there. We see, question said in a box of numbered balls. Okay, and balls are numbered like 1, 2, 3, and 4, such that the probability of drawing a ball is proportional to the number on the ball. Right? What is meaning of proportionality here? Anyone?
One is
number
proportional
one,
to 2, 2 is proportional to 3, 3 is proportional to 4.
no,
No.
number
That's
one
I
has
think, sir,
probability
one is
something
proportional
as
to one. So Proportionality means the probability of 1 is getting 1 by 4 and probability of getting 2 is 2 by 4 and 3 by 4 and so on.
No, I think
When there
I
is
took
a
I
one
took
ball,
it as
then
for one
Yeah,
point
one
one,
second.
but
One second. Listen
point
to
one
me.
one
Listen
ball.
to me.
if
Yeah, listen.
one, sir, can I explain?
Yeah.
4 will
Yeah,
contain
if
4 balls.
like I considered probability of 1 is x, then
Yes.
probability of 2 is 2x,
2x and
probability of
probability of
3
3.
3x,
Yes,
and
yes,
probability of
yes.
4
Yes,
is
sir.
4x.
Yeah, you are right. You are right.
Me too, sir.
Yeah, that's
K
right.
will be 0.1.
Yeah, K will be point. That is something you had to think. Like suppose I said numbers is the proportional, I mean probability is something which is proportional to
But
the,
Prashant, I simply took point 1, point 2, point 3, point 4. I also got the same answer.
yeah, it's okay.
Because it's number, right?
If you,
For
yeah.
one, it's
Sir,
proportional.
what I did, I added
See,
all
see.
the number and divided it from it
See,
one by
see,
one.
if you put point 1, point 2, point 3, point 4, then you will get the same answer.
Yes, yes.
Yeah, that's actually that is the meaning of something, you know, you had to think proportional to the number. That means suppose suppose a proportionality constant is k, for example, then 1 is proportional to 1 times k, 2 is proportional to 2 times k, and 3 is proportional to 3 times k, and 4 is proportional to 4 times k. And all of you know by the property of probabilities, sum of the total probabilities should be 1. Okay.
Yes.
That is okay. That means k plus 2k plus 3k plus 4k equal to 1. That means k is equal to 0.1. But in the question, you had to find the what is the expectation of number on the ball drawn. So what will be the answer? See, it will be 3 because and you know expectation.
Yes, sir.
Yeah.
No, sir.
Sorry. Yeah.
Yes, sir.
See, yeah, expectation is something in which you have to
The mean of a random variable in long run, sir.
yes, that's correct.
Yes.
That means x into px means that value of random variable into corresponding probabilities. Then all the possible values of random variable we have to multiply it with the corresponding probability. Here x can take values 1, 2, 3, and 4, and corresponding probabilities is 0.1, 0.2, 0.3, and 0.4. Okay. That means 1 into 0.1 plus 2 into 0.2 plus 3 into 0.3 plus 4 into 0.4, which will equal to 3. Is it clear to everyone?
Yes, yes.
Okay.
Yes, sir.
Yeah, fine. And this, see, remember this was the prelude. So you have to use this value and concept in this question 1, right? I think it will take hardly 3 to 4 minutes. in this question, you can use the property of expectation, right?
Okay, sir.
Excuse me, sir.
Yeah, hello.
Yeah, sir. Actually, I joined late, so I was not able to solve prelude question. Actually, I didn't had a low point prelude question. So can you just?
Yeah. See, in the previous one,
Okay, sir.
one second. This was the question, okay? And in this question, you had to find what is the expectation of a number on the ball, okay? For it's in this question, it is asking about only one question. Oh, sorry, only one ball, right? And for one ball, answer was 3. Okay.
Okay, sir.
Yeah. Just do it. We will check the solution.
Okay, sir.
And people who have not joined this session, kindly enter on your phone or laptop joinpd.com, and after that you will have to enter this code, top right corner code, JTL UJI, and then you will came on this phase, these slides, and after that we continue with us.
Sir, when can we expect the result? Please.
You will be notified today. I think it will, yeah. Okay, so all of you are able to solve this question, right? There are only 24 responses. So can't they do it?
Um,
Yeah, it is.
Sir, I'm getting confused in solving this question.
Okay, no worry. We will see the solution within a minute. Okay.
Okay, sir.
Yep. Yep. Okay, we will wait for 1 more minute. After that, we will see the solution. I think we should go for the solution, right? Or are you trying? Hello.
Yes, sir. Go for the solution.
Okay.
Yes, sir.
Let me see the responses first. 9, 1.4, 18. Okay, a lot of variations. Yeah, see, just tell me, have you got the concept of this question? If a ball is drawn at random, then what will be the expectation of the number on the ball drawn, right?
Yes.
Hello. Yeah. It was clear to everyone, right?
Yes, sir.
Yes, sir.
And in
Yes.
this
Yes, sir.
question, suppose in this question, it has been asked, if a group of 3 balls is drawn at random from the box, then what is the expectation of the sum of the numbers on the balls drawn? What will be the approach?
The first we will
For
find
a
out
ball, see, for a single ball, it was expectation of the 3. So for a 2 ball, what will be?
Uh,
6. See, let xi, see, we can see the solution.
so
Xi be the expectation of the number on the ith ball drawn. Okay, and you had earlier 4 ball, but in the question it has asked you have to draw a group of 3 ball, right? That means x1, x2, and x3, right? And for a single ball, the expectation of a number on a ball at drawn at random, it was expectation was 3, right?
yes, sir.
So
Yes,
for
sir.
3 balls, that means expectation of x1 plus x2 plus x3,
Yes, sir.
Yes,
and
sir.
you know for a single ball expectation is 3, so it will be 3 times 3, that is the 9.
Oh my God.
It's clear.
Yes,
yes,
sir.
sir.
Yes,
Suppose
sir.
suppose question was like if you
I
draw
got.
no 2 balls, then answer will be 2 into expectation of x, right? then you will get the answer as 6 instead of 9.
Yes.
Okay, is it clear to everyone?
Yes, sir.
Okay, so we can move for the next question.
Excuse me, sir.
Yeah, please go ahead.
Sir, if a ball where numbered 3 is drawn, then the expectation of another 3 will not be changed. Like the 3 balls are remaining. Ball numbered 1, 2, and 4. Then their expectation will not change.
Actually, I did not get what.
Sir, he is asking simultaneously or separate, one by one.
Yes.
Sir, maybe he is asking about a different question.
No. Actually, see, can you repeat? Can you more elaborate?
Sir, the question is that the group of 3 balls are balls is drawn. Okay. Then if we draw a ball, then if we drew the another ball, then expectation will not change.
Okay, you are. Yeah, I got. I think I understood. See, for drawing a ball, okay, you had 4 ball initially. Okay, if you draw a ball at random, then for a single ball, expectation was 3.
Yeah.
Okay. Suppose I draw a single ball second. Suppose I draw second ball. Okay.
Yes, sir.
Again, for that ball, expectation will be 0.3.
Yes, sir.
Sorry, 0.3. It's 3.
Yes, sir.
Yes.
Okay. Suppose I draw a ball that was a third ball. For that ball also expectation can be 3.
Yes.
So I had draw 3 balls simultaneously. 1, 2, and 3. That means for 1 it was 3, for 2 it was 3, and for third it was also 3. That means 3 plus 3 plus 3. It's clear?
Sir, what is the meaning of expectation?
It's the long-term mean of
yes. See, expectation is something. See, can you tell me? You can say it's as a theoretical average. Okay, means suppose you roll a die. Okay.
Yes, sir.
And what will be the expectation of the rolling a die? It will be around 1 plus 2 plus. It will be around 3.5.
3.5.
Yes. Yeah. So expectation of that means you can expect average of large number of rows. Okay.
Okay.
Not a single row.
Okay.
Yeah, you can expect in a long run. Long run average of large number of rows. That is the meaning of something expectation. It's kind of theoretical average. Okay, in the long run.
Does it mean that it will be the expected outcome if lot of
trial? Yeah, lot of trial you are.
So here, if we say the expectation is 3 in this case, so does it mean that out of the 4 numbers, 1, 2, 3, 4, that can be possible outcomes? If lot of runs are done, then the most likely outcome would be the ball with has 3 on it. Is that how we can understand it?
Yeah. You can interpret like, suppose I roll a die. Okay, then I will get for expectation 3.5. Okay, so if you this meaning of 3.5 is not like you can expect outcome to 3.5. This is not the meaning. Okay. Meaning is that you can say you can expect the average of a large number of rows to be in the long run.
Okay, but we can't say that since it is 3.5, so either 3 or 4 will be more likely.
Kind of.
Okay.
Can we say it as a weighted mean?
Not.
Yeah, it's weighted mean.
Yeah, it's weighted mean.
Yes, I think. Yep.
weighted mean of
Because
random
sir,
variable.
for even here number the ball is there, na? So for the 4 we have bet
Yes.
more weight for that.
Okay, so yeah, so this is the next one. So I think you know how to find this expectation of any function. Okay, just I will give you it. Just put the values of x, and you will get things. Probabilities will not be changed, right? This is the basic hint. Okay.
Yes, sir.
Yeah, probabilities will not be changed,
Okay, sir.
and but values of gx
Yeah,
will be
function
changed.
will change.
Yeah.
function will-
Sir, meanwhile, can I ask one doubt? Hello? 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 Hello?
I think he's not.
Hmm. Sir? Sir?
Yeah. Hello.
Meanwhile, can I ask one doubt, sir?
Yeah, please.
In lecture 10.3,
Okay.
when ma'am was telling that example of this related to this question only, in that in that 15,000 that what is that bonus is there in that. Hello?
Yeah.
That 15,000 bonus is there. While explaining, ma'am said ax plus b is there, na sir? So b ax here in first part of example is 0.9x. Hello.
Yeah. I think.
And
I
did
have-
you are you correlating with my doubt?
No. Actually, I have to check.
So example question is Sanjay and Anita work for the same company.
Okay.
Anita's Diwali bonus is a random variable whose expected value is 15,000 rupees.
Okay.
Sanjay's bonus is set to equal 90% of Anita's find the expected value of Sanjay's bonus. Okay.
Mm-hmm.
So 9.9x is the y for the
Okay.
Sanjay bonus. Huh?
Yes.
So EY is 0.9 into EX,
Mm-hmm.
which is equivalent to 13,500.
Yeah, whatever.
So this is for the she was explaining that a into ex plus b is the equation. Okay.
Yes. Okay.
For here she said not here in the second part of this example, if Sanjay's set of Sanjay is set to equal 1,000 more than Anita's, find his expected bonus.
Okay.
So in this case, y is equal to x plus 1,000. Hence, EY is equal to EX plus 1,000, that is 16,000. Okay.
Okay.
Logically understood. But when ma'am was telling, she said EX plus 1,000. So 1,000 is the B.
Yes.
And there is hidden A there. For that, she said A is 0. A cannot be 0, na? Because that is multiplying. A is absent, but not 0, na?
Okay, I think
A is 1 there.
1 we cannot say also, but we can say that A is absent.
Okay. Your doubt was age 0. Okay.
Ma'am is telling 0. Okay.
Okay. I will check the lecture. Okay.
I'll tell you the time, 12.37 minutes in lecture 10.3.
Okay. I will check. Okay. So I think there are enough responses. So we can check the solution, right? Yeah, there are a lot of variations 5.2, 9.25, 4.4. Okay. Let's see the solution. How you can find the value of x square plus 3? Just put the value of x is in the place of, in the function of gx, right? And x can take value -1, 0, 1 and 2 from the given table. So for x equal to -1, what will be the g of -1? It will be -1 square plus 3, that is 4, right? And for x equal to 0, it will be 3. For x equal to 1, put 1 in the place of x, you will get again 4. For x equal to 2, you will get 7. And random variable is something. Here gx can take values, the possible values. What are the possible values? 3, 4 and 7.
Yes, sir.
Right?
Yes.
Till this point, it's clear to everyone?
Yes sir, वहाँ पे जो
No, sir,
decimal
no,
points
not
दिया था ना
here, sir.
0.25 वगैरह, that
Yes.
that should not be used at all.
Sorry.
Can you please go back to the question, please?
Yeah,
हाँ,
it
यहाँ
will
पे,
be used. It will be used. This probabilities, you are talking about probabilities, right?
yeah. So
Yeah, it will be used.
directly you put this value, na, x is equal to 1.
No. See,
Then,
it's for, see, we put the value of x to find the possible values of gx. Okay.
so here we did not use, na, directly we put x value and put that.
See, solution is there. Again, is the solution. No worry about that. See, suppose, one second, let me open my Jamboard. Okay, one second.
Can you show the solution once?
Yeah, this one, right? See.
No, next page.
Yeah.
This is the solution.
See, till this point, is it clear to everyone or not? Just tell me.
Then why not 4?
Why
Why
logically I am understanding, sir, but ma'am has told it very differently.
Okay.
I am maybe I am getting confused with the
Yeah.
idea.
You can
property of
reverse.
expectation.
Yeah. See, now see. Here, how you can find the expectation of something? How can you find the expectation? Suppose I'm saying expectation of x. Okay. That means summation x into probabilities, right?
Yes, sir.
So suppose I have to find the expectation of some function of x, right? What is this x? This is x, this one. That means summation of gx into probabilities for x.
Yes.
That is the concept. So here, see here, you had value of x minus 1, 0, 1 and 2, right?
Yes.
Okay. So for each x, you have to find the value for gx.
Yes.
Okay.
Only
so how
the value
you
of
can
x will change.
Yeah. So it will be changed, but probabilities will be
Yes,
same.
same.
That is the concept.
Same. Yeah.
Okay.
Yes.
So here.
Now you are only calculating the gx value. Okay.
Yes. Here you are, we are calculating only gx. Okay.
No, my doubt is why g of x is taking values 3, 4, 7. Why not x equal to -1? Why?
Sir, see,
it's taking 4 values, right?
It's taking 4 values, and 4 values are 4, 3, 4, 7.
Okay, fine. Understood.
Okay. See, if you put the x equal to -1, there are 2 values
You
same.
take out the repeated one, I think. In
Yes.
Fine, clear.
Okay. So let's move for the next one. And
no,
you
sir,
know,
I still have doubts, sir.
Yeah. Please ask.
Sir, I still have doubts, sir.
Yeah. Please. Go ahead.
Sir, when ma'am was explaining this, sir, she said ax plus b. So x square is there. So only x will be x squared and not the addition will be there.
Yes.
So what I did, x squared. So my gx -1 is 1 and then 0 is 0. I did not add 3 there.
Why?
Logically, function wise, okay, sir.
One second, Prashant, I can clear this doubt.
Yeah.
Actually, here we can approach 2 methods, like directly instead of x, we can calculate x square plus 3, like what now Prashant is showing. This is one method.
Yes.
Another method, what you are telling, what ma'am told, that method is simply you can do ex square plus
And
3.
plus
You
3.
are knowing the value of ex square and you are simply adding plus 3. That is the formula ma'am gave. E of ax plus b.
See. You can do.
Ex plus b.
You can do
Yes,
like
that's
that.
what
Okay.
her doubt.
Yeah, you can do like that. Okay. See, you can find expectation of y. That means expectation of gx. That means expectation of x square plus 3.
That's what she is asking. I think so.
So x square expectation is value of x square I will take. So if x square, if x is -1, so x square will be.
Just tell me how you will find the x here, meaning expectation of x square. X is -1, 0 and 1, 2. Okay.
So
then
x
you have
square
to
will
find
be 1, 0, 1 and 4.
Yeah,
Okay, sir.
expectation of x square. You have to multiply this quantity
And-
into probabilities.
And
This
then
quantity.
multiply with each of them probability, then
Yes.
add them.
Yes.
And then finally add 3.
Yes.
Yes, yes. Both will
Yeah.
give same answer.
Both will give the
Okay,
same
Both
answer.
methods will give
Okay.
same answers.
So
No
what is
See,
the
see.
answer, sir?
Answer is
5.
answer is 5.2.
Yes, sir. That is my
Both is the
Both
both is
methods
see
will give
Okay,
either
okay. I
see,
got
see.
confused. Huh?
No,
Got
no,
it,
no,
got
no,
it.
no, no confused. See,
Ah.
either you can put the values first and then find the multiplied by probabilities and find
Sir,
the expectation,
I got the
or
same value. But here
no,
logically
no,
I
no.
was able to understand here, but I was
Yes.
not able to correlate it with this equation.
No, now
Now
are
got
you
it,
able to
got it,
correlate,
got
right?
it, got it.
Okay, okay, fine. Is it clear to everyone? Yeah. See here, values of gx we get 347. Okay, and at what value of 3? I mean, what will be probabilities for gx equal to 3? It will be same for 0.
Yes, sir.
0.15 and GSC. Remember this one. Gx equal to 4 you got for two probabilities, means -1 and 1.
Yes, sir.
Right? So it will be added the probabilities 0.1 plus 0.3. That is the
Actually, here
yeah.
matrix method is only better instead of doing all this. Na? Keep
Okay,
the
okay.
matrix, make a square.
Okay, see.
There only in the box.
Both
That's
are
it.
correct. Both are correct. Which is
That's the easy method to calculate.
yes, whichever is comfortable to you, you can apply it. Okay, I think now you got the concept of how to find the expectation of function of that random variable, right?
Yes, sir.
Sir, I'm not sure what's being discussed, but what I did was I found the expectation for x first and then calculated x square plus 3, and it also gave me that same 5 point.
This right?
I did the
Yeah.
E of x. Okay, it's already been discussed. Sorry.
Yeah, it's already had been discussed. This is also correct approach.
Okay, sir.
Okay.
I did it for x. This one shows x square. So what I did was E for x, and then found out what is g for that value.
See, your function was x square plus 3.
Yeah.
Okay.
And I did the E of x. And then I calculated, so I got the value 1.1. And then I plugged it into the gx equation and I got 5.2.
Okay.
Is that coincidence?
One second. You how?
No, normally it won't happen. You won't get, because the g of x square is not equals to g of x whole square.
Yeah.
Not
You are.
always.
I think you have tried this one. Okay.
Yeah. So this comes out as 1.1.
It's I think by coincidence, because see your gx is x square plus 3.
So 1.1 square plus 3 comes out to be 5.2.
Yeah, okay. See.
I don't know if it's
yeah. See, but logically it will be like this. Okay.
Because E of x square is not equals to E of x whole square.
Yeah, it's a different thing. It's a
someone has tried
for
with
some
ex square.
For some values, for some values it can equal. For
it's
some,
not E of x whole square, sir, that I did. What I did was E of x, and then I did that 1.1 square.
See. You did expectation of x. Okay. You got 1.1. Okay. And you did 1.1 square. Okay.
Plus
so what is this? What is this? This is you did this one, right?
Okay.
That is by coincidence. By coincidence, you get the correct answer, but this one is the wrong.
Okay.
Correct one is this.
Okay. So what I did was G of E of x, which is not expected to be.
Yes. Yeah.
Maybe you have taken 1.1 square wrongly, because 1.1 square is 121, no? 1.21. So it cannot be.
Yeah, it can happen. It can. Yeah.
Maybe you have done some calculation mistake.
Yeah.
Math mentioned clearly this one, it's not equal. Math mentioned
Here
several
itself it
times.
is not
I missed
equal.
the lecture. So
Here itself it is not equal.
Now,
That's why I was checking.
just tell me, you people got this concept, right? This
Yes,
approach
no.
and this slides approach, right? Is it clear to everyone?
Yeah. Slide approach
Okay.
clear.
Okay, so we can move, right?
Yes, sir.
Yeah, this is the nice question. You can think a little bit. Okay. How to approach this one? Just try to think what distribution can apply here. This is a hint from my side. Yeah, are you getting the concept behind this question?
Yes, sir.
Okay, fine. Yeah, continue this. There are 20 responses. So let's
Sir,
wait
I've
for.
not seen lectures yet. Could you explain a bit about the question so that I can
Oh,
try some?
okay, okay. See,
Thanks.
okay, just think about it. After that, see, then we will see the solution. You will get more idea, right? And this is something where you have to apply the distribution. Okay.
Okay, sir.
Yeah, yeah. So there are 21 responses. Yeah, 22 responses. We will wait 2 to 3 minutes more. After that, we will check the solution. Right? Just listen us carefully and do with us, and you will get a more idea for.
A simple probability concept will get the answer also, I think.
Yeah, it will give. But if you know the distributions, then you can try it directly. That's what I mean to say.
Which type of distribution you want to say? Is a binomial, Poisson, and like that?
No. Kind of. Okay. Not binomial, not Poisson, but kind of. There is a distribution.
Random variable distribution, sir?
No. What is there is nothing like the random variable distribution. I will tell you. No worry about that. Just you can see.
We can think.
Yeah, you can think.
Yeah, actually,
talking about the dark chocolate.
Yeah, you
the
can.
random variable can take value 0, 1, and 2.
Listen to me. This is just something.
Yes, sir.
Yeah, someone said hypergeometry. Yeah, that is the correct distribution. Actually, yeah, you can apply it by probability.
Simple probability concept will give the answer.
Yeah, it will give the answer.
Okay, sir. Thank you.
Yes, sir. I have find the probability by using the simple method, but I am also thinking on this.
We'll get by simple method also. Easy.
Random variable distribution, sir.
Hypergeometry.
Yeah, you can do by this.
Because I'm guessing the next question will be based on that, I think.
Okay. Okay, so there are 23 responses. Let's wait for 1 more minute. After that, we can.
But sir, I request you to explain the distribution when you explain this question.
Okay. I will explain the concept behind hypergeometry.
Okay, sir. Thank you.
Yeah.
What concept is there in the 5th and 6th video, sir?
5th and 6th video?
Ma'am lecture, I did not see. Till 4th only I watched.
Okay. Till 4th, I think it was about variance, right? And 5th and 6th, it's about properties of variance and standard deviation of the random variable.
Standard deviation I have not seen.
Yes. You can watch.
Will be explaining today?
It's a concept of variance. Vicky Kumar. Yeah, concept of variance and standard deviation are covered in these slides. Okay, and for more clarification, you can watch the video.
Yeah, I'll be watching.
Yeah.
But now.
Yeah. Now, see, in this session, concept of variance and standard deviation will be covered. I think we can see the solution. Let me see the responses. Right, or should I wait?
No, sir, you can go ahead.
No, sir, go ahead, sir.
Okay, there are variations. Okay, 0.53, 53. No, today I did not get majority with same answer. See, there are in total 10 chocolates. Okay, of which 6 are milk chocolates and 4 are dark chocolate. So 2 chocolates are drawn at random without replacement from the box. So in how many ways you can draw 2 chocolates out of 10 chocolates without replacement?
10C2.
That will be the total sample space?
Yes, sir.
Fine.
Yeah.
And in the question it has been asked, what is the probability that one dark chocolate is drawn?
It's 4C1.
It will be 4C1 into?
Yes, sir.
into
4C1 we can choose a dark chocolate, and in 6C1 we can
choose the another one. That is the answer.
milk chocolate.
Yes, sir.
That is the answer. That is the answer.
Yeah,
It's a
yeah,
very
correct.
easy one.
Yeah.
Okay.
This is the yes, sir.
Yeah, actually there is a concept of hypergeometric means, see, you know, hypergeometric, suppose you have a box, okay, in which you have you can say capital N balls in total, okay, right? There is some background noise. Okay, suppose you have to choose a sample of a small N ball, right? It's okay, and you choose the this randomly and without replacement. Okay, suppose out of these N balls, your M ball are red, then how many ball will be of another color? Suppose I'm saying N minus M ball are suppose yellow color. Okay. Hello, am I audible?
Yes, sir.
Yeah.
Yes,
So
sir.
suppose you have a box in which you have total capital N balls in total, out of which you have M red balls and N minus M ball are yellow. Suppose another you can suppose as a blue, black, whatever, and I choose N ball without replacement. Okay, this is the sample. So, and suppose your X is denoting, suppose my random variable is X and it's denoting number of your red balls selected. Okay, then distribution of probability of X equal to I. I means what is how many sample you are choosing, up to N. So this variable can take value 0 to N. It's clear. Suppose X equal to 0 means 0 red ball. Okay, so probability for this will be MCI into capital N minus M, N minus I divided by capital NCN. It's clear. Means this is the total sample space. Out of total N balls, you have to choose small N balls. Okay, and what is X? X is representing the number of red balls, right? How
Yes,
many red balls? I red ball. Okay, so it will be MCI, and remaining N minus I ball will be chosen from the this one.
Yes,
it's
sir.
clear to everyone.
Yes,
Similarly,
sir.
here it was the same. Means 10. There were 10 chocolates, out of which 6 were milk and 4 were dark. Right?
Yeah.
Okay.
Yes, sir.
So
Yeah.
your probability was X equal to 1, means 4C1, remaining 6C1 and 10C2. That means you have to choose you had to choose 2 chocolates, out of which one was dark chocolates and remaining was okay. Now it's clear.
Yes, sir. But I must say that this probability X equal to I, which you have written in the screen, it's very complicated to see, sir.
No. See. I means suppose I said X equal to 2.
No, I understand the whole concept, but it looks very complicated.
Okay, no. Just try to think. Now it's clear to everyone.
Yeah, yes, sir. It's clear.
Okay. Suppose I say X equal to 3, then it will be simply MC3 N minus N, N minus 3, whatever your N is there. Okay. And total sample space will be in the denominator.
Yes.
Right.
Okay. Thank you, sir.
And this is something, it's called the hypergeometric. And suppose I said find the mean of the hypergeometric, then it will be N into M by capital N.
Yes,
capital N. Yeah.
Okay, you can directly calculate this one, or you can calculate by the concept of expectation of X into GX. Both are correct, but this for direct you can do this.
It saves time, sir.
Yes. It saves. Yeah. Now this is something which I had give to hint, so you can do it within I think 2 or 3 minutes will be more than enough for this question.
So could you please show the Jamboard where you had written that because we have that will make it very easy.
Okay, this one, right?
Okay. Yes, sir.
N into M
Thank
by
you.
N. Okay.
Okay, sir. Thanks.
But see, these things you can try manually also. You can calculate the expectation by the formula, means summation of x into tx, but it will be more complex, but this will give the same answer.
Okay, sir. Thanks.
Yeah.
So meanwhile, can I ask a doubt, sir?
Yeah, please go
And
ahead.
so my knowledge is very limited. I must acknowledge I've not seen many videos. I'm very sorry if the question doesn't make any sense for you, but because we studied
No,
about
Mhm.
Bayes theorem, so I was just wondering the question here, if I had not known from which week or for what formula to put, I would start to think that is it related to something that is Bayes rule? Can we interpret it in that way? So
For this question.
explain that.
For this question.
Yes, sir. Because
it's not kind of Bayes theorem actually.
Because
the
reason I have the doubt, sir, is because it talks about, we already know they are dark chocolates, no, sir. So I mean, in this, what is fixed and prior knowledge is that these chocolates are going to be dark, and
okay.
then
See, here first thing, here it question is not about the finding the probabilities. First thing, okay, it's about expectation number. Okay, expectation.
Okay.
And see, you are thinking Bayes theorem, so Bayes theorem will not be applied here, because see, Bayes theorem is something you have, you suppose you have 3 events. Okay, suppose 2 events, E1 and E2, and one event, any one event F is occurring with that 2 event. Okay, let me one second.
Yes.
Yeah, Bayes is something, suppose this is your sample space. Okay, and your 3 events, suppose this is the E1 and E2 and E3 is there. Okay, and one event F is occurring here. Okay, this is, suppose this is the F. So Bayes theorem is something, when I said you have to find the probabilities of E1 given F.
Okay, so they
No, I think E1 given F. I think it's right, Rahul. Please correct me, I think.
So what is F?
F is something which occurred for whole.
So 2 chocolates when some are dark and some are white.
See.
So
Yeah, that is the another things here. Okay.
So actually, I don't find any type of conditions here. So
No. Actually, see. She has asked about the Bayes theorem. That's why I did this here. Okay.
Okay.
yeah,
I'm
sorry. Sorry if I'm
sorry.
deviating from it. Yeah.
No.
Okay, I'm sorry.
Yeah. See, Bayes theorem is something. Suppose I'm saying here, I have to find the events of, suppose I said ki F has occurred. Okay. And you have to find the probabilities when your F has occurred, and you have to find the probabilities of E1. Then you have to apply the Bayes theorem. That will be like probability of f given E1 into probability of E1 divided by probability of f kind of. Okay, this have got this one or not?
Yes, sir. And the denominator comes out to be sum of
Sum
f
of
given
the
an
all
E.
the
Okay. Okay, sir. Thanks.
Yeah. You can try interpret, but this is the different one for this. There is some prior knowledge, posterior knowledge kind of things. Okay, so I think there are 57 responses. Let's wait for 1 or 2 more minutes. After that, we will see the solution. And you can do this question by the formula of expectation rather than using the concept of.
Yes, sir.
Yeah.
Yes, sir. Actually I have done it in. At first I just arrange a distribution. Then find the probability of that part, that is 0 dark chocolate, 1 dark chocolate, and 2 dark chocolate. After that, I have calculated the expectation.
Yes. That will give the
Okay, sir. Okay.
Let's wait for 1 more minute. And
time consuming, sir.
Yeah, it will take time. If you know, if you identify the which distribution is applied, then you can directly calculate the things.
Yes.
But for a cross checking, you can do by manually. I think very less people are trying the questions. I don't know why. Maybe the reason was not completing the video lecture, right?
Yes, sir. I mean, I tried because I knew this one, but one question I could not even try because not doing the lectures. Week 9 is also pending for me, so I have 2 weeks worth. Yeah. Thanks.
Okay, no, I think 9 and 10 you can cover in very less time. There are not.
Tomorrow is the last day for submitting the assignment.
Yeah. Actually, schedule was kind of disturbed, but we have to manage somewhat. Okay, so I think we can see let me see the responses of you. 0.8, 0.8. Okay, 0.1, so more or less 1 marks. Okay, 0.8, 1.066. Yeah. Okay, see. You know the mean of the hypergeometric distribution?
Yes,
N,
sir.
yeah. Nm by n means n is capital N is something which is your total sample size. I mean, sorry, your total chocolates, right? And m is something which you can take it as sample size, or n is something which your dark chocolates, number of dark chocolates. So your number of dark chocolates is 4, and you took the sample of size 2, and so it will be 4 into 2 divided by 10. That is the nothing but 0.8. Okay, this is the something which is the you can do by the hypergeometric thing. Okay, hypergeometric thing means, suppose you have n and I took the n sample size. Okay, here suppose it's the sample size. Okay, out of which suppose m are red. Okay, and capital N minus m or blue ball. Okay, so what will be the probability? It will be MCI n minus n minus I divided by capital NCN, and the expectation of x, it's n into m by n. Okay, it's clear. You can interpret as m. Suppose here I can do m sample size and red, then it will be n minus n. Then it will automatically change m instead of m. So whatever it is, no worry. See, here your
For,
x is
for milk chocolate, it will come 1.2, na, sir? So it will become 2. 1.2 plus 0.8 is equal to 2.
see, yeah. And your x can take value 0, 1, 2. Okay. What is x? X is number of dark chocolates. Okay. So what will the probabilities? 10C2. Okay. What will the probabilities?
So for the first, that is 6C2 divided by 10C2.
6C2 divided by 10C2, right? And
Yeah,
for
right.
one means one dark chocolate, it will be
That is 0.5K, which we have calculated earlier.
Okay. This is this one. And for 2, it will be 4C2 divided by 10C2, right?
Yeah. Yes, sir.
If you multiplied by, see, if you applied the concept of expectation, that means summation x into px. So it will be 0 into this quantity plus 1 into this quantity plus 2 into this quantity, and you will get the
0.8.
Have anyone did like this?
Okay, yeah.
Okay,
I
you
got
got this one.
0.79, which is approximately equal to 0.
We are getting 0.79.
Okay, okay, that's
you see, approximately equal to 0.
Yes, yeah.
Actually, I solved all the expectation questions with simple primary school methods.
Yeah, actually, I have done it in the same.
Primary school methods. Like, see, 4 dark chocolates and 10 total chocolates. So, in 2 total chocolates, how many dark chocolates will be there? Just simple. This is the cross multiplication. That's what I did.
Yes.
Entire expectation questions I solved like that only. I never use the formula in math big time.
Yeah. Yes, see, approach everyone in the
But that's the easiest method. Can you explain that method also? Then people can adapt it easily. That's the easiest method for
this
knowing
one,
expectation.
this one, or regarding this one, this one.
No, expectation. Now there are just 4 dark chocolates in 10 total, right?
Okay. See, this was the little bit simple. I mean, there was only 3 values. Okay, and you did this one. Suppose I took the sample size of 10. Okay, suppose in total I have 20 chocolates, and I took draw the 10 chocolates, out of which there are suppose whatever n are milk chocolates and m are dark chocolates, and n minus m are milk chocolates. Then it will be more difficult to do, like multiplied by the all the probabilities, right? It will more complicated. So that's why in that situation you directly applied the concept of expectation, that is nothing but n into m by capital N, where n is your
instead of this formula also, what I'm telling, simply we can do in total 10 chocolates, we are having 4 dark chocolates.
Yes.
So in total 2 chocolates when we draw,
yes,
how many will be there? It's 4 by 10. Simple, simple.
Yeah. Simple mathematics.
No need
Yes,
to remember this formula also. That's what I'm telling.
Yeah, that's no worry about.
Sanjay, can you repeat it again?
अभी चार चॉकलेट्स है 10 चॉकलेट्स में दो में कितना होता है बस
Yes,
this
actually
formula
apply.
only, but no need to memorize this formula.
Yeah, actually it's a simple mathematics, but you can remember the formula also, and you can do manually also. But if there are only 3 to 4 possible values of random variable, okay, but you can simply do like there are 4 chocolates, 4 dark chocolates. For being 2, it will be 2 into 4 by 10. You can apply the both, I mean all the approach, and these 3 approaches will give the correct answer. Now it's clear to everyone the expectation of x.
Yes, sir.
Is it okay for everyone?
Yes, sir.
Yeah, okay. So I think
Sir, actually, if the instead of getting the red one, like if it will ask for two different balls expectations. So how will we proceed?
2 different ball expectation means?
Let us say out of it is only asking 2 balls, 2 black balls, no?
Yes.
So 2 dark chocolates, right? If it will ask like
then random variable different.
So we'll not use this formula, right?
No. Random variable different. Okay. What is the concept of hypergeometric actually? Means you had, in 10 chocolates, okay, and you choose a sample of 2 or 3 chocolates. So out of those 10 chocolates, suppose you have 6 milk and 4 dark, okay, and you choose the sample of 2, right? So in how what will be the expectation? That means expectation of that random variable will be your sample size, okay, that means 2 into how many chocolates are there, means suppose I am asking about dark chocolate, so it will be 2 into 4 by 10, right? There are no, you can say inverse type of things, means one is dark, then again it's remaining are milk. Suppose if you're talking about the pen, so suppose M are black pen, then N minus capital N minus M will be blue pen, kind of. Two varieties you can say.
Excuse me, then
Yeah.
in that case, can we do it in one by one method? One for the blackboard, suppose the quantity for black needs to be selected is 1, and for the blue, the quantity selected to be 1. Then can we select M as 1 into 4 by 10 plus 1 into the 6 by 10? Can we select like that?
You are
Suppose, for example, out of the 10 balls,
yes,
4 are blue and 6 are black.
okay.
So can we calculate in this using the same formula, nm by 10? For blue, it will be suppose we want to select one blue ball and one black ball. And in this case, can we select
actually see, it will depend on what is your random variable is there, what is your x,
blue
okay
ball?
Suppose I'm saying x is representing the number of black pen,
okay
then what will be then you have to find the expectation of x. Actually x can represent only one thing, okay. And for expectation of x, suppose you are choosing the sample of 3. So what possible values x can take? 0, 1, 2, 3. Means what is x? X is number of black pens. It can 0 black pen, 1 black pen, 2 black pen, and 3 black pen, right?
Okay.
So and here you can apply the with probabilities, okay. Or you can directly apply this concept, this simple mathematics concept.
Okay.
Yeah.
Thank you.
So yeah, thank you. We can move for the next question. It's clear to everyone, right?
Yes, sir. Yes, sir.
Yeah, this one also nice. You can try it. Okay. Yeah, here you can think like what are the possible values of x is taking with the corresponding probabilities. So first apply the concept of expectation, and after that you can apply the properties of the expectation, means summation of random variable kind of things. Okay. And more you can emphasize on the independence. Are you able to understand the concepts here? Hello.
No, sir. Can you explain it?
Yeah, see, just.
For one match, we will calculate the expectations for winning.
Yes, and
then
then
we add
yeah.
for 5 matches.
Yes. See, just week 10 is about. See, week 10 is about expectation and variance of the random variables. Till now, you got the concept of expectations, right? How you can calculate the expectation of a random variable. And in the first question, if you remember, you know how you can calculate the expectation of 3 random variables, the summation of 3 random variables.
First question is like that.
Yeah. So that is the
This is
similar.
just a Bernoulli's experiment, right?
Sorry?
This is a Bernoulli's experiment, right?
Yes. Bernoulli experiment.
Actually, week 9 and week 10 are much easier in comparison with week 5 and week 6.
Yes. Week 5 and week 6 is something where you have to know. Suppose you are thinking, yeah, this will be the possible cases, but when solution is there, then you will get, yeah, my approach was wrong, kind of things. Somehow, any of the cases, some of cases left with us. Sometimes we forgot the sometimes cases where we have to come. Yeah, here I can apply the combination. Yeah.
Graded assignment is very tough.
Graded assignment is not like this type of question.
Yes.
No, it's there is
The first graded question, we will actually apply a hypergeometric formula and
see. First
we
question.
will calculate expectation for one.
Listen to me. First question is, this first question of this slides. You can think like.
Yeah, we can apply this concept. Yes. This one.
No. What is the first question? First question is there. One second.
Ball. 4 balls, numbered balls.
Okay, 4 numbered balls, and there is some proportionality concept, right?
Yes.
Okay, same, and it was the same as the first question which I applied in the.
So first we calculate expectation for choosing one.
This and yeah, and for the summation of their numbers.
And then we add for 15.
Yes.
Okay, sir. Thank you, sir.
Yeah. Okay, so I think there are 23 responses. Okay, we will wait for 1 or 2 minutes, and after that we will see the solution kind of things. Someone said week 1 graded was best.
Excuse me, sir.
Yeah, please.
In first question,
Mhm.
I asked that question. I asked that if one ball is drawn,
Mhm.
then why the expectation of another three balls are not changing?
See,
Yeah,
what is the listen to me. What is the expectation of drawing a ball?
It's 3, sir.
3. Do you know which ball you are talking about? It can be first ball, it can be second ball, it can be third ball, it can be fourth ball.
Yes, sir.
So expectation of drawing a ball means any one of the 4. It's is 3.
Yes, yes.
Okay.
Yes.
It will be 3 for first one. It will be 3 for second one. It will be 3 for third one and fourth one also. And if suppose you are choosing the 3 simultaneously, then there will be summation of the expectation.
Yes.
Right?
Yeah. Okay. Okay, sir. Okay. Now it's clear. Yeah. Thank you.
Okay. Fine. Fine.
Yes, sir. We can see the answer, sir.
Yeah. Once. Okay. I think you can see the responses. Let me see there is 3, 3, 3. Okay. This is the first time majority is. See. You know, for a single xi.
Yes, sir.
Yeah. Okay. What is your xi? Xi is the random variable associated with the ith match, and you know, for a single, what are the possible values xi can take?
0 and 1.
0 and 1, and with 0 probability is 0.4, and with 1 probability is 0.6.
Yes,
right?
sir. Yeah.
See, then it's for only one ith match. Okay, it can be first match, it can be second one, whatever. So expectation of xi will be 0 into 0.4 plus 1 into 0.6, which is 0.6.
Yes, sir.
Okay, and in the question it has asked about the 5 matches. Okay, and this expectation of xi was for one match, right? So for 5 matches it will be expectation of x1 plus expectation of x2 plus expectation of x3 plus expectation of x4 plus expectation of x5. Okay, and this is something okay, you have you remembered the Bernoulli random variable? Okay.
Yes, yes.
See, this is just something Bernoulli random variable is something. It takes the only 2 possible values, 0 and 1. 0 for something you are failure and 1 for success. Okay. Here failure was suppose you lost the match, and success is you win the match. Okay. And probability is associated suppose with 0, 1 minus p is there, and for success probability is p. Right. So what will be the expectation? That means 0 into 1 minus p plus 1 into p, that is nothing but p. This quantity will be 0, this quantity will be p. So your expectation of x will be p, right? And suppose I'm saying expectation of 5 matches means x1 plus x2 plus x3 plus x4 plus x5. What will be this? This will be expectation of x1 plus expectation of x2 plus so on plus expectation of x5. Okay, right? For each one it's p. It will be 5 times p. Are you getting my point?
Yes,
yes. Okay, so here what is p? P is 0.6, that is 3.
Okay, sir.
Okay.
Sir, I
Yeah.
have a question, sir.
Actually,
Sir, can you show me
sir, can you
the
please go back to the
question?
question, please?
Yeah, this one.
No, please go back to the here.
Sir.
Okay, sir, actually what I did now, it is asking expected number of wins. Okay, so what I did here, x is equal to 0, niche note diya hai, x is equal to 0 if team loses, and x is equal to 1 if team wins. So what I considered x is equal to 1 only, and that point is p is equal to 0.6 alone. Then winning of 5 matches, I directly multiply 5 into 0.6 rather than going into 0 into 0.4 plus 1 into this.
Yeah, you see, you get the correct answer, but what things is your possible values for each is for each xi is 0 or 1. 0 for you lose the match and 1 for you win the match. Means possible values for one match is 0 and 1. Okay, suppose it's -1 and 1, then you will get the different answer.
Yes.
Okay, that's why, see, somehow you got the correct answer. It's okay, but just try to think what are the possible values of these two xi, 0 and 1, right?
A -1, 1 only.
Okay, and what is the probability associated with this? 0.4 and 0.6.
ये तो समझ में, ये तो I understood, but
Okay.
actually मैंने
I will come to that point. And you know what will be the expectation for each xi? Means 0 into 0.4 plus 1 into 0.6, which is nothing but 0.6.
0 and
okay.
Yes.
So for 5 matches, it will be expectation of x1 plus x2 plus x3 plus x4 plus x5. It will be 5 into 0.6, that is 3. Okay, suppose instead of 0 1 I can take value, suppose -1 showing for loss and 1 is showing for win, and for -1 probability is 0.4 and it's 0.6, then automatically you will get the expectation of xi as 0.2. Right?
Yes, sir.
Yeah, so
Sir,
you got
yes,
the concept. I mean, you have to consider both possible values, not a single value. Okay.
Sir, I have one question, sir.
Yeah, please.
Sir, here we are finding the expected number of wins.
Yes.
What will happen when we will find the expected number of loss?
Okay. So just tell me this one. I am leaving on you this thing. Okay. This is the expectation number of wins in 5 matches. So what will be the expected number of losses in the 5 matches? Okay. I'm leaving on you. Just think about this. It's a good question.
Yes, sir. I have a question.
Yeah, please.
Yeah, sir. Actually, hello.
Please.
Yeah, sir. If in this question, given that the total number of matches is 10, then what will be the approach of this question?
Total number of matches is 10.
I think I just want to say that if in the question it is given that the football there is total 10 number of matches, and then what is the expected number of wins in 5 matches?
Okay,
and the x equal to 0 for if team loses and x equal to 1 if team wins, then what is our answer?
Then you will go like that. Okay, you are considering about 5 matches. Okay, then it will be like your random variable take 0 1 2 3 4 5. Okay, you can win you can win 0 match, you can win 1 match, you can win.
Then for x equal to 0, the probability will be 0.4, and for x equal to 1, the probability will be 0.6, for x equal to 0.6, and so on.
but yeah, but you are see, then there will be probabilities for each values.
Yeah.
Okay, see here there are only two possibilities, 0 and 1. That is the another thing. Okay, but suppose if you are like taking in the consideration like 10 matches and 5 matches, then for each values probabilities can be different or whatever, but probabilities will be different. But here its probability is given only for two values.
Okay.
Okay, here probabilities will be different, like that in the previous one, if you have remembered this one.
Yes, yes.
For two chocolates, your x value x can take value 0, 1, 0, 1 and 2, and for 0 probabilities you have to find. For 1 you have to find the probabilities, and for x equal to 2 you have to find probabilities. It's clear here. It's a concept about only two possible things, means your failure and your success.
Okay.
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 Yeah, fine.
So here x equal to 0, x equal to 1, x equal to 2 is a number of matches.
Sorry, x is not, see what
here
is
x is a ith match. Here
yeah,
I is the ith match, but in my question there is I is not the not the ith match, it's the number of match.
Yes, then it will be 0, 1, 2, 3, 4, whatever you number of matches be. Okay, and probabilities will be changed.
Okay. Got it. Thank you, sir.
Yeah, thank you. So yeah, it's clear to everyone now, this concept, how to apply the properties of summation of expectations.
Yes, sir.
It's clear to everyone.
Yes, sir.
Yes, sir. Okay.
Yes, sir.
Okay, so I think we can move further. Yeah, see, now till this points you yesterday, I mean, you solved the expectation. Now the things comes variance. Variance is meaning of something, spread of the values, how variability is there. Okay, see, expectation is something, it gives to you a theoretical average, right? But when, see, expectation does not give the information about the spread of the values, how much your values of the random variable is spread. And variance is something which gives the information about the spread of the values, about the mean or average of the random variables. Means, see, variance of a random variable is expectation of x square minus expectation of x whole square. This is something which which is the formula of variance actually. See, in general, see, focus on this statement. Variance gives the information about the spread of the values, about the mean or average of a random variable. See, that is the meaning of something. See, your variance is something, expectation of this average of the values about the mean of this. In the previous week, variance formula like 1 upon n summation xi minus x bar square.
Yes, sir.
So can you correlate this one?
Yes,
what is x about this mean and square, and what is expectation? Expectation is summation of something, addition and whole things.
Yeah.
Right. So here variance is something. What is variance? Variance something, spread of the values about the mean. Spread of the values about the mean. Right. And you can do it like, expectation of x minus mu is something, mean of the random variable. Okay, you can interpret as mean, and you can do like this. You can explain this one, minus 2. It's okay to everyone?
Yes, sir.
Yes, sir.
Okay, minus 2 mu is constant. Here will be expectation of x, right? And I said mu is something mean of x. Okay, so this is something. Okay, so I can write it expectation of x square plus c. Expectation of 9 is 9.
Yes, sir.
Okay, so mu is something. What is mu square? Mu is something constant. Okay, then it will be 2 times mu, and this is something mu. What is expectation of x here? I'm assuming expectation of x is mu, right? So here it will be expectation of x square plus mu square minus 2 times mu square. It will be expectation of x square minus mu square, which is nothing but variance of x. The variance of x, expectation of x square, and mu is the told you
of x the whole square.
Yeah, mu is the something expectation of x. So what mu is the expectation of x square. This is something variance formula. So you can remember the variance of x is nothing but expectation of x square minus expectation of x raised to the whole square. It's clear to everyone?
Yes, sir.
Yeah. So this is the something variance of the random variable. And you know what is the standard deviation? Standard deviation of random variable is nothing but the square root of the variance, right? So whenever you have to ask about the standard deviation of a random variable, it's nothing but the square root of the variance. It's clear to everyone?
Yeah.
Yes, sir.
Yeah. So we can move for the question. Yeah. See, and you know the concept of variance. Suppose I'm saying variance of x1 plus x2. What will be this? And your x1 and x2 are independent.
Variance of x1 plus variance of x2.
Yes. If, see, there is condition. If your x1 and x2 are independent, then variance of summation of this equal to variance of x1 plus variance of x2. If your x1 and x2 are not dependent, then you cannot say variance of x1 plus x2 equal to variance of x1 plus variance of x2. You can't, I mean, you cannot say if it's dependent. It's independent, then this equality will hold.
Sir, can you go to page number 13?
This one?
Yeah, just
सर ये सॉल्व वाला पेज आप अपलोड करेंगे क्या?
So no, I think uploading not. You can watch on YouTube or you can take a screenshot also.
okay, sir. Fine.
Fine. Now just remember this property. Okay. If xi's are independent, then your summation, whatever it's, I mean, suppose instead of 2, I have more variables, means summation of I equal to 1 to 4 xi, then it will be summation of I equal to 1 to 4 variance of xi's. Okay. And condition is that your xi's are independent. Right? It's okay. This points is
Yes, sir.
understood.
Yes.
Yeah.
Yes, sir.
Understood. Okay, so just apply the that concept, and here it's mentioned that independence of the matches. Okay, so you can directly calculate this one. Is everyone able to solve this question?
Yes, sir.
Yeah.
Trying, sir. Trying.
Yeah. Just try.
Sir, I think this part will be used here, sir.
Yeah, it
The
will be
result
used
of the
in the.
match is independent of the other matches.
Yes. That's why it's mentioned. Okay.
Yes.
If properties of variance means, suppose your random variable, you have suppose 3 random variable x1 and x2 and x3,
Yes,
and
sir.
those are independent, then in that only case your variance of x1 plus x2 plus x3 will be equal to variance of x1 plus variance of x2 plus variance of x3. If it's not independent, then these things will not be
Variance
equal
of
to.
5x will be 5 square variance of x.
Yeah, that is the also property of
Independent.
property, and one property of variance is something like that. Suppose variance of a times of x, a is any constant, so it will be a square variance of x. Yeah, try to apply these two properties here. In this question, first try to find the variance of xi for ith match by the formula of expectation of x square minus expectation of x raised to the whole square.
Yes, sir.
And after that, apply the concept of property of variances.
Excuse me, sir.
Yeah, please.
Sir, I have some doubts in activity questions. Can you take that after this?
Okay, we'll take this.
Okay, sir. Thank
you. Yeah. There are 14 responses. Okay, so we wait for a couple of minutes. Are you trying, or should we go for the solution?
Yes, sir. We can go for the solution.
So, is for everyone?
Yeah, done.
Yeah. Okay. Nice. Let me see the responses first. Okay. 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 No worry. See. You know how to find the variance? Okay. See. Variance of x. X is something. Expectation of x square minus expectation of x raised to the whole square. So in the previous question, you find the expectation of x, right? How? X means values of x into corresponding probabilities plus 1 into 0.6, which is nothing but 0.6. It's clear? Expectation of x square means square of the values of x into corresponding probabilities plus 1 square into 0.6 equal to 0.6. Was everyone able to solve this expectation of x square?
Yes, sir.
Fine?
Yes, sir.
Yeah. See, you know what is the variance of x? Means expectation of x square minus expectation of x square. So your expectation of x square was 0.6 minus 0.6 square. It's coming out to be 0.4. Right? But
yes,
it's for only ith match.
Only one.
Okay. But in the question, it has asked about what is the variance of number of wins in 5 matches. Right? So for 5 matches, that means your variance of s, okay, it will be summation for the 5 times. Okay, it will be 5 into 0.24, it will be 1.2. Okay. For each xi, it was 0.24. Okay, means variance of x1 was 0.24, variance of x2 was 0.24. Similarly, a variance of up to x5 was 0.24. Okay, so variance of, I say, see in the question it's mentioned that your xi's are independent of each other, right? When your random variables are independent, then variance of x1 plus x2 plus x3 plus x4 plus x5 will be summation of the variance individual. Okay, plus variance of x5, and this is 0.24 plus 0.24 up to 5 times, right? It will be 5 into 0.24, which will be 1.2. It was clear to everyone?
Yeah.
So then dependent cases में क्या होता है? What exactly
See,
we have done in dependent?
in the dependence case, this will not equal to this one. Because if you see, suppose I am saying x1 plus x2, in the dependence case, it will be variance of x plus variance of x2 plus covariance of x1 x2, it comes. Okay, but suppose x1 and x2 dependent, then there will be some concept, some values for covariance. That's why it will not equal to. If x1 and x2, suppose x1 and x2 independent, means there is no relationship between these two, means there is no linear relationship. Then in that case, your covariance term will be 0, and variance of x1 plus variance of x2 will equal to this one. Okay.
Okay.
Sir, that 0.24 could have been also obtained by multiplying p into 1 minus p.
Yeah. See, actually, this was the concept beyond the which was based on the Bernoulli. Okay, in Bernoulli, your x is 0, 1, and probabilities is 1 minus p and p, and in the Bernoulli, your expectation is p, right? And your variance is what? It's p into 1 minus p.
Yes.
Okay, and p is 0.6 into 0.4. You can directly calculate 0.24 variance of x. Okay, and see, it was for 5 random variables, so summation it will be 5 into. That's why I said, see, that's why I said, if you remember the random distribution and direct expectation varies, so you can do it directly within a very less time. Okay, or you can do manually also. It's clear to everyone?
Yes, sir.
Hello. Yeah.
Yes, sir. Yes, sir.
Yeah, okay. So let's move for the last question, and you can attempt it. Okay, try. But this is just about properties of the expectation and variances.
Second one.
Just attempt the choose the options.
Yes, sir. Done, sir.
The third one.
Yeah.
Just let's wait for rest of the people. There are 15 responses. Let's wait for 1 more minute.
Excuse me, sir. Sir, may
Yeah,
I ask a question?
yeah, please.
Sir, it is not related concept. Can I?
Yeah, please go ahead.
Sir, like if there is a relation between x and y, like x and y are variables, so its covariance is 0.
If the variables are independent, then covariance will be 0.
Sir, like in quiz, there was question. So it the variance for sample standard deviation was given for variable x, and we have to find the covariance between the two x and y. So what it means, like there was option given 0 even, and here
Okay,
you
okay.
have a formula.
No. Actually, I said for if your variables are independent, then covariance will be 0. That's why variance of x1 and x2. See, variance of x1 plus x2 is equal to variance of x1 plus variance of x2. Right?
Yes.
If
Yes.
it's not dependent, means if there is some if it's not independent, there is some linear relationship, there is some relationship, that's then there will be some values of covariance. Okay, we'll give you the solution.
Okay, sir. Thank you, sir.
Yeah, let me see the responses for this. Okay, 1 and 3. One second, let me. 1 and 3, 1 and 3, 1 and 3. Yeah, majority is 1 and 3. Yeah, that is the correct answer. See, why second is not correct? Anyone?
Yes, sir.
Why?
Because here B is added, which is incorrect.
So B is added, it's okay. Why it's not equal to?
Because the variance of a constant is 0, I think.
Adding a constant not affects variance.
Will not change the
Yeah,
variance.
not
Yes,
affects
sir.
the
Yes.
actually at all. See, first option is clear by the properties, and second is also clear. See, I will explain why second is not clear. Suppose, let me just go for the, suppose my, suppose your initially, yeah, please, yeah. Suppose your initially random variable is x, and finally it was let me as y equal to ax plus b, for example. Okay, then what will be the expectation? Expectation will be a times expectation of ax plus b. Expectation of something is constant, so it will be expectation of x plus b. It's clear? Okay, and suppose I'm asking about variance of y. What is meaning of this one? Means expectation of y minus mu square, mu whole square. Suppose expectation of y is mu, for example. It's clear to by the formula of expectation. Hello.
Yes, sir.
Yeah, is it clear? So just tell me what will be the this one, y, ax plus b, right? What will be the mu? Mu is again expectation a times of expectation of x plus minus b. It's clear?
Yes, sir.
Then this b will be cancelled out by this b.
Yes, sir.
Is it clear to everyone or not?
Yes.
Yeah, it's clear, sir.
It's clear. Then a will come out to be outside. Then it will be a square expectation of x minus expectation of x square, and you know this quantity is nothing but variance. So variance of y is equal to a square variance of x, where y is nothing but ax plus b. Means you, if you add the any constant, means variance of ax plus b, so addition that will be does not affect at all. It will be a square variance of x. Why it will be a square? Because this a when you will take the common, it will be a, and it will be when you take this outside, it will be a square. It's clear to everyone?
Yes, sir.
Now you got the concept of properties of expectation and variances, all those things.
Sir, I have questions, sir.
From which? Where?
Activity question 10.
Yeah, one second. Let me summarize this. Okay, you all of you know the Bernoulli 0, 1 with proper probabilities 1 minus p and p. Then mean is p, variance was p into 1 minus p, right? And you had applied the hypergeometric things. Okay. What was the mean of this one? Anyone?
In m by capital M.
N into m by m.
Okay. And let me clear this frame again. Okay. You know the expectation of x, how you can find? Summation of x into px, right? And suppose I'm saying expectation of xi, summation of xi, it will be summation of I, expectation of xi, right? And suppose I'm saying variance of summation of xi, it will be summation of variance of xi. When your xi's are independent. It's clear?
Yes, sir. Yes, sir.
Okay. Okay, so I think that was this one, and thank you everyone for joining this. Yeah, someone has asked about the activity.
Yes, sir. Activity
Yes,
10.4, question number 3.
10.4, right?
Question number 3. option second and third.
Okay.
If the variance of a random variable is 0, then the cardinality of range of a random variable is 1. But actually, I didn't get it, sir.
See. You understood the second and third, right? Sorry, third and fourth, right?
No, the second and third. Second and third. If the variance of a random variable is 0, and as the size n of uniform random distribution increases, variance increases.
Okay, you don't get this point, right?
Yes, sir. Second point and third.
And third one. Okay. See, it says if the random variable, variance of a random variable is 0, then the cardinality of range of a random variable is 1. Means see. Suppose I'm saying variance of a random variable is 0. Okay.
Yes.
That is when variance will be 0. Variance of a constant will be 0.
Then there will be no
then your
space.
x can take only one value.
Variance of a constant will be 0.
Yeah, it's always.
Okay, sir.
Then see, what is the here? Then the cardinality of a range of a random variable is 1. What is meaning of cardinality?
Number of items in that set.
Yeah. Then in that item it will be
only one constant number.
Yeah, that's why it will be 0.
Yes,
right?
sir, I got it. Okay.
And the next question is, as the size of the uniform random distribution increases, variance increases. Okay, what is the uniform random distribution?
And
your uniform random distribution
probability of each random variable is equally likely.
Equally likely. See,
yeah,
your random variable was suppose taking this value, and probabilities was 1 by n, 1 by n, 1 by n.
Yes, sir.
Okay, what is the expectation?
Expectation is n plus 1 by 2.
And what about variance?
Variance is n plus 1, n square minus 1 by 12.
This one correct?
Yes, sir, it's correct.
What I think it's n square minus 1 by 12, right?
Yes, sir.
Okay, and if you see the option, what is option? As the n size of the uniform increases, variance. Suppose I took the n as 1. Okay.
Yes, sir.
So your variance will be 0.
Yes, sir.
Suppose n as 2. What will be your variance?
Okay, okay, sir, I got it.
Got it?
Yes, sir. One more question, sir. Last question, sir.
Yeah, please.
Activity question 10.5, question number 3.
Okay, this is about opera theater. Okay, so can you tell me what was your approach?
No, sir. Actually, I was asking you for the approach only, sir. I didn't understand this question, sir. How should I approach this type of question?
See, what is the question? Here, properties of variance will be applied. What is the question? Variance of a number of tickets sold in a day an opera theater is 25, right?
Okay, sir.
So, what is given? Variance of number of tickets sold in a day, right?
Yes.
So, you can interpret as variance x as number of tickets sold in a day, right?
Okay, sir.
And its given variance of x is given 25.
Yes, sir.
Okay. What is the again? If for each ticket sold the profit obtained is 25 rupees, then what is the variance of profit obtained in a day, rupee square? See, each ticket profit was 25 rupees.
Yes, sir.
That means, suppose your x is number of tickets, and for each ticket you got the profit of 25 rupees.
Yes, sir.
What will the profit for two ticket?
50.
What will the profit for 3 ticket?
75.
Means 3 into 25. Okay.
Yes, sir. Yes, sir.
What will the profit for 4 ticket?
100.
4 into 25?
Yeah.
Similarly, what will be the profit for X tickets?
25x.
25x. So you have to find the variance of 25x.
Okay. Yeah.
Okay. And you know variance of AX is nothing but A square variance of X.
Yes, but
it will be 25 square into variance of X, and 25 square is nothing but 625 into variance of X 25. You will get the correct answer.
Okay.
Right?
Okay, sir. Thank
Okay.
you. Thank you, sir.
Thank you. So we can, I think, close the session. It's too late also.
Okay, sir. Good night.
Okay. So bye bye everyone. Good night.
Okay.
Thank
Bye
you,
bye.
sir. Yeah.
Thank you.
Bye, sir.
Thank you,
Bye.
sir.
Bye.
Thank you very much.
Bye.
Thank you, Prashant. Thank you so
Yeah.
much.
Thank you. Thank you. Bye.
Thank
Bye,
you,
everyone.
sir. Thank you. Good night.
Good night. Good night.
Good night,
Is
sir.
there any problem today? Why this session delayed?
Actually, I was outside in some
Okay, okay.
medical
Is
regarding.
everything fine? Is everything fine?
Yeah, it's everything fine regarding some medical issue. I was outside. That's why it's
Okay.
started to. Yeah,
So how are you now?
I'm fine now. It's fine.
Okay, fine.
Okay.
See you.
Yeah.
Bye-bye.
Okay.
Good night.
Bye. Good night. Good night, everyone.
Thank you, sir. Good night.
Yeah. Thank you.